want to thank everybody today for coming. Joel Turner has been very nice to help co-host the meeting, and that makes it where he can help get everybody online. I don't have to worry about that so much and sort of have my eyes dancing back and forth on different screens and all the rest of that. So if you came here via the email that I set out, on my mailing list, that means likely you already know that this is going to be a meeting, or it's going to be a Sunday workshop that'll be all about questions and answers. A few people have sent questions and answers ahead of time, and I very much thank them. One of the things about questions and answers in this kind of topic is the questions and answers could be actually pretty complicated. Excuse me, I'm going to get a cough drop. I have a bit of a cough. And so it's nice to prepare. However, if during this meeting you have some questions, please bring up the chat window in Zoom, put your questions there, and as soon as they get through the 4 or 5 that I have here that came early, we'll get down to your questions and answers. One second. So the last workshop, the topic was tips and tricks. And if some of you weren't able to attend, the video is still available on a link that you can find on my website. That's woodworking.digital. And that link will be active for a little while. I'm going to have to move that video. Eventually, it'll end up over on YouTube. I'm recording this meeting, and this also will eventually end up on YouTube, or there'll be some other link. And in order to find out, to see the video of the workshop that we're doing today, again, go to woodworking.digital, and there'll be a link. I'll upload it in the next day or so, and we'll kind of go from there. So the first question I have, and I hope he's here, is from Greg Cromines, and you have to forgive me if I mispronounce names. I tend to do that a lot. It's an unfortunate problem that I have. So Greg, his question is a very good one. He said, I'm a furniture maker and would like to have a CNC to make templates for his furniture. How would you recommend I get started with a CNC? It's a two-part question. Let's start with that first one. The how you get started question is actually very, very simple. And simple in the sense that I always give the same exact answer. And the way you get started, no matter what, is to start to learn CAD software. CAD software is the barrier or the thing that you have to leap over in order to do anything related to a CNC. Excuse me. Pardon me. Anyway, no matter what you do, you need to learn how to draw using these digital tools. There are no real shortcuts. Now, I know that CAD can be very intimidating for a lot of folks, but it doesn't have to be complicated kind of CAD for doing woodworking or furniture making. Believe it or not, as complex as CAD software gets, what we do as woodworkers is very, very easy. It's a very low level kind of CAD drawing that you have to do. Myself, I learned, I started out a million years ago by using drawing programs to help myself do my work as a graphic designer. And those drawing programs are very close to what CAD programs are, except CAD programs have a lot more capability. I happen to start that way because I did all this long before I even became a hobbyist woodworker. So start off with, by picking a CAD program. There are all kinds of possibilities out there. One of the ones that come up a lot is Fusion 360 because it is technically free. I say technically because Autodesk has a tendency to make things that are free or open and bring them in and later charge you for it. But for now, it's free if you are not using it for a big commercial kind of use. I say big because if your business is under $100,000 or there's some barrier like that, that's one possibility. And then there is various CAD software you could buy. I happen to use a piece of CAD software called Rhino, which I absolutely love. It was a long decision for me to choose that out. If you've not committed to CAD or if you're looking around at CAD, I encourage you to at least try it, have a look at it. They give you a 90-day total usage. You could use it. There's nothing inhibited or anything else. And anyway, it's well worth looking at. One of the reasons I like it, its user interface is really great. And I like that a lot. I use it for other reasons technically related to the kind of work that I do, which is some more advanced 3D stuff. So learn CAD. Now, the next step in terms of getting templates, you do not need a CNC to get templates made. I've written articles about this a couple of times for Popular Woodworking. If you have a drawing that's simply an outline kind of drawing, so if you have a shape like this, for example, you could cut that out of a piece of MDF or plywood or whatever, and then you have a template or a pattern. So for a long time before I bought a CNC, I actually went to a service and they would cut out all my patterns, stacks of them over here. So here's a whole bunch of them here from when I used to do these patterns a lot. So learn CAD, learn CAD, learn CAD, learn CAD. Second part of his question is really about a CNC itself. He said, what size bed would you recommend, and are there brands you'd recommend that you should consider? So, let's start off with the practical part of the question, and that has to do with the size of bed. So if you're a professional woodworker, I know some of you are not, but just think about how a professional woodworker would approach the problem. So all of the equipment I have in my shop, and I have about an 1,800 square foot shop here, all of the equipment is sized to do the machining and whatever else I'm doing with the size of the pieces that I make. And my goal is to aim that my equipment can essentially scale up to, not scale, but my equipment can cover 90% of the size of problems I have to solve. So for example, I build dining chairs, dining tables, casual seating, on and on, benches of all sizes and stuff. But occasionally, for example, I have to build 8-foot long benches. That's really long. So I don't have some things in the shop that make it easy to do something 8-foot long. I'm not going to go buy equipment to make something to do 8-foot long. But I will make sure that I have equipment to do something, say, 6-foot long, which might be, some kind of surface or a bench or something like that. But so for those 10% of times when your equipment doesn't work or it's a little undersized, there's always a woodworker way around it. For example, behind me is my CNC here. I had it custom built. It is sized toward most of the kind of furniture that I would build. The bed area back here is about a little over 3 feet this way, and it's 6 feet this way, plus there's some overhang down on this end. Now, I actually make 12-foot pieces on this bed because I can push things through. And so the answer to Greg's question is size it toward the kind of furniture that you think you're going to make. Now, I know a lot of people buy very small CNCs like 12 by 18, sometimes 18 by 24. But if your goal is to make furniture, I encourage you to consider getting a larger CNC. In this shop, for example, I have a Shapeoko XL, which I believe is, let's see what size, it's about 32 by 16 cutting area. Now, I could pass stuff through up to 32 inches wide in there. So that means I could build something bigger. But if you're going to build furniture, I would think about trying to get something closer to 3 or 4 foot square, because that would cover all kinds of dimensions for like a dining chair legs and part of a top and stuff like that. You can get there for sure with a smaller CNC, a 2 foot by 4 foot platform, and that will work great. But think ahead a little bit. And if it matters, then maybe you aim toward a 4 by 4. I also have a 2 foot by 4 foot or 2 foot by 3 foot CNC over here. And because the length is the area that the gantry crosses over, I'm able to move stuff through. So my real width is 2 feet wide, which covers almost everything that you could do for woodworking. I mentioned earlier that I size my equipment for around 90% of the problems I have to solve. So I have a white belt sander in here, and I always thought I was going to end up with a 30-inch or 36-inch white belt sander. But I started to realize that 90% of the problems I would deal with really aren't really that wide. If I need something really wide, I'd go out and I use a service that has a 46 or 56 sometimes to sand the top. So in the case of my sander, it's only a 15-inch wide sander, but it's open on the sides. So think ahead about what you want to do, size your CNC toward the problems that you have to solve. Try to hit an 80 or 90% point for all the things that you do. In the case of a furniture maker, it'd be nice to have a CNC that could cover 2 foot by 4 foot or maybe up to 4 foot by 4 foot. CNCs have a big footprint, and that's always part of the contingency. The last part of the question is, what brands do you recommend? Well, frankly, there's a lot of really good CNCs out there. You know, Laguna has a line of 2 foot by 3 foot CNCs plus 4 foot by 4 foot, and then 4 by 8 and all the rest of that. Axiom Precision makes very, very similar CNCs. They're 2 foot by 4 foot. These are pretty powerful CNCs. They use big spindles. They're water cooled. They can do a lot. But lower price, at that point, you can get into the Shape Ocos. And there's some new CNCs coming online. I know there's many other brands. I can't remember them all at once. So in any case, do look around. Think about your longer term use. And at the other end of the equation, don't start thinking that you need a 4 by 8 CNC. Maybe you do. If you're doing cabinets, you need a 4 foot by 8 foot CNC. But if your focus is on furniture, it's a bit of overkill. And one practical piece of advice before I end that answer: despite the size of this CNC, most of my work is done in only a quarter of it. Everybody I know that has a CNC, professional woodworkers, we all have the same story. So next question is from, let me look on the back, I just wrote it down. It's from Joel Turner, who's been co-hosting in this event. And let's see, he wanted to know about converting drawings into a CAD format so you can actually CNC something out. So it could be that you have a photograph of something and you want to be able to, you know, make a drawing from it, or you have a print document. Maybe there's some sort of plan or something like that. The answer is there are no particularly easy ways to do this automatically. There are some tricks that'll kind of help you along the way. I can tell you, as a designer who has had to deal with this in the graphic design world and industrial design world, most of the time you just have to kind of redraw it. So the practical part is, if you had a photograph of something, say you had a photograph of an object again like this, and you have a JPEG file, bring it into your CAD program and then trace around it, and then you're going to get your curves correct. The same thing would be true if you had a drawing. There's no big shortcuts. The big thing is to get the scale and the dimensions correctly. So when you're pursuing something like that, make sure that you have important scale information for reference. So another question, let me reach down here. This is a good one. I actually prepared something for it. It's from Michael, and he said, I'm working primarily in plywood of 1/2 inch. Even if I use small passes, I've broken a few end mills that are 1/8 inch bits that are 5/8 inch long. They are not strong enough. What type of 1/8 inch bit would you recommend? Well, 1/2 inch thick of anything, whether it's plywood, and an 1/8 inch bit is bound to break something. The solution around this is you need to use bigger bits for your initial passes. And if it's detail you're after, and he sent some pictures, I don't have them available here, where there's some detailed things for signs and some other things that he's done. The thing is hog everything out with a larger bit, and then go back in with an 1/8 inch or a smaller bit as necessary to do the little details. I'm going to bring up a drawing here that I had prepared to make the point. Let me see here. There we go. So let me see here. I didn't hit share, my fault. Sorry about that. Share screen. And there we go. Hopefully everybody can see this. So I just did this little zigzag thing here to make a point. So this happens to be 1 inch thick, don't worry about the thickness, it's just what I happen to make this. So the problem that you have in terms of detail is what's always referred to as the inside corner problem. This shows up in CNC work all the time. So the problem is not so much going around the outside like here, hopefully my cursor is showing up, Problem is you get to the inside corner and a big fat bit in there is not going to get into the detail. Again, outside corner, you can go around the outside, but inside corner, it's going to leave a bunch. So I'm going to actually simulate a run with this. So let me see here. I'm in Rhino Cam, by the way, which is a plugin for Rhino. That's the CAM software that I use. It's actually made by a different company called Mexsoft. They have freestanding versions of this. Okay, so if I simulate, and I put a chunk of wood in there for to simulate if it was cutting out. And I didn't cut all the way through. Please ignore that. I did it this way just so you can kind of see what goes on. So in this case, I used a 1/2 inch bit. Again, I'm just trying to simulate. So you can see as it comes around the corner here, it leaves this big fat chunk here. And that's what you would cut with a smaller bit, is that big fat chunk. Now also notice that there's a little bit of yellow left here. That's excess wood. And here's why. So again, I went through there, I went around here, it's tight to this corner, it's a little bit wide here because of the diameter of the bit. So there's a couple of ways to solve this problem. The first way is to make a double pass. And this is the easiest if your CAM software is not particularly sophisticated. So I made the first run, in this case with a 1/2 inch bit. And now one of the things that I did is I left excess on the outside. And excess so that the final pass with a smaller bit is actually going to trim off that excess as well as cut into the little corner down here at the bottom. So the way this was set up, I'm going to go into my settings for this. And again, this kind of stuff shows up in all kinds of CAM software. So if I go into cut parameters here, I left right in this area here, I left 5/1000ths of an inch extra stock. In other words, I didn't cut to the line, I cut a little bit outside the line. It's an offset as it is. And so that is this excess stock that you see here, this little kind of gray line here. And the reason I left that is so I left it to the smaller bit to come back in and clean it up. So I'm going to go into this. And now, so what I did is I did a routine now that's the same vectors or curves. I'm going to run around the same area as before. But now I'm going to cut off that excess 5/1000ths of an inch. And I'm going to tuck into those corners a little bit better because I'm using a smaller bit. And again, I use a 1/4 inch bit just because it's easier to illustrate on this screen. In your case, with an 1/8 inch bit, you might make your first passes with a 1/4 inch bit and then go do cleanup with your 1/8 inch bit. And this is the simple way to do it. So now I'm going to simulate this pass. You can see it going around and see it clean up the corner. At the same time, it took off some off these walls here. And now I've gotten in tighter. Now, needless to say, a smaller bit, if I had to get in there, I could use an 1/8 inch bit. So that's how that works. But turns out there's a second way to do this if your software allows for it. So I'm going to simulate again. And now I had it as before. I left a little excess here around the outside, in this case 5/1000ths. There's that big inside corner. There's a routine in more advanced CAD software called remachining. In my case, in Rhino Cam, it allows for that. So my second pass will do something very similar to what you saw before, except instead of running all the way around the outside, it's just going to go in and remachine the areas that the big bit could not get into. So I'm going to simulate it. And in this case, I didn't leave excess on the wall, but what it did is it simply worked in the area that the smaller bit would do. So rather than run all the way around the outside, it just tucked into here. So if I was doing that process myself in this routine here where I did that initial where I left 5/1000ths extra, I wouldn't leave extra. I would do cut right to the line, and then I would go back in with my remachining routine and just clean up those little corners. That's called remachining. So let's get back to that. So hopefully that made a little bit of sense. It's hard to get into that. in too much detail. So I'm going to ask a question from Jim and Ashley. He says, I already have Aspire. Any reason to check out Rhino software? Uh, it's worth checking out to see if it's something you like. Aspire costs quite a bit of money. Rhino's kind of similar range. There are ways to get, did I just get cut off? There we go. There are ways to get Rhino for around $700. If you had education thing, you can, I'm not sure how come I'm losing that. There's an education pricing and a lot of software that can be a little bit cheaper. But functionally, Aspire will get you most of the way where you want to go. It has a number of 3D features, a number of carving features, etc. One of the reasons I prefer Rhino over Aspire is its capability is considerably farther. It goes out a lot farther, and that's definitely one of the things that matters to me because I do a lot of sculptural work. And another thing is Aspire and their other products make an attempt to sort of redefine and rename and kind of mask what's going on in straight CAD terms. For me, that bugs me a lot. I really want stuff straight. I don't want to try to hide what's going on. I want it straight. I want the information. I want the routines called what they are. You know, remachining is a standard in the high-end CAM industry as a term. Profiling, contouring, you know, all the other routines. I just like it. But in reality, you can probably get anywhere you want with Aspire, and if it works. So somebody looks like Jewel. Okay, so do you have predefined reference holes on your CNC table to screw your jigs to? You have those reference holes in your CAD software and you design your jigs around them. Does that take care of XY zeroing? And I see a giant plus sign on your jigs that provide a final XY0, or is it a combo of both? It's actually, in the case you're referring to some jigs I'd showed previously, I have those on there. The answer is really both, because I know I sometimes move my jigs to other people's CNCs or even my own CNCs, and my predefined positions on the on my bed here are known, but I could move things and slide along a slot if I wanted to position outside of a rigid position. And with that X on there, that X is exactly 2 inches from the XY origin. And so I do both. I like having the options. It allows me to work on the fly. I don't necessarily have to work about bolting something down on the table. I hope that answers it. Does it take care of your XY zeroing? I want to make sure I clarify that. I have both a camera and a laser system with offsets to my spindle centers. So all I have to do is line the laser up into the X on there, and then it's offset into the position of the spindle. So let's see, if there's only one plus sign on each jig, how do you know the jig isn't out of square? Well, reason's pretty simple. All the jigs are made on the same CNC. I know that they're square. My CNC is square. I go to a fair amount of trouble to make sure that it remains square. So if the jigs are right, if the bed is right, then you're able to put the jigs on the bed in an exact position. And you're also able to line up to anything on that jig and be correct. It works out really good. So next question. Well, anyway, I also want to say, I hope that answers your questions, Michael, about the issue of using small bits. I would never use an 1/8 inch bit to cut a 1/2 inch piece of plywood. I'd use an 1/8 inch bit to do an inlay on there, but I sure as heck would be using bigger bits. They're more robust. They won't break as often. Just take your time, and if you have to get some detail, go back in an 1/8 inch bit. So now, a question that I can't really answer well. This is from Steve Corwin. He says, I'd like to learn more about two-sided workpieces, flip milling. How do I set up my CNC in CAD for it, and how do you maintain alignment when you flip it over? Would you cut all the way through from one side into a spoil board, or cut 2/3 the way through both sides? Well, I actually have given classes particularly in this. I will tell you that they take a week, so it's nothing I can answer really quickly or easily. It's just you know, the way that it is. It takes a long time to kind of get into all the details. I'm going to give you a bit of a preview. At some point, I might do a class that has to be way beyond our 40-minute time that we try to do in a workshop. But here's a couple of principles. So I have here a bowl that was 3D carved. And just in case you didn't know, it's actually a flattened bowl. So the basic principle would be, how do you work both sides? And in this case, I'm going to turn it this way here. Now this is easy, it's symmetrical. There's a center line through here. So the basic idea, the basic principle is that you would machine one side, and then you'd flip it over on the same axis. Let's call this the x-axis, and then you'd machine the other side. And that's the basic idea. So let me see, I think I have a drawing of this here. Drawing of something here to, let's see if we can get into that here a little bit. I got lots of drawings here in here today. There's one missing, unfortunately. Give me 1 second. There we go. Okay. What you see right now is a spoon. And I'll show you a little bit here what it looks like. This was one of the dummy tests here. It's all mounted onto something. So, okay. So my apologies. I'm going to go back to the screen that we were showing. And let's get into that. So this is the drawing of a spoon. And it's a two-sided operation. So the last thing I left off with is, notice down here, this is my X, Y, Z coordinate system down here, right down in here. And what I do is I actually use a jig in order to do two-sided machining. And by having a jig, I'm able to take a part and remove it, flip it over, and put it back into the jig in the exact same position. In order to do that, I have to have a common coordinate. And in this case, the origin point down here. So what I have showing here is the top horizontal roughing, which is the first pass. I'm not going to go through a simulation here, but you can see all of the lines that are in here. And notice that I have these little stabilizers stuck in here that'll hold the spoon in place, because you can't release it in the middle of the function. So I've actually put these in here with the idea that later on I can cut them off, sand them smooth, plane them, do whatever. The second part of the run is the fine run. You can see these little patterns down in here as I zoom in. This happens to be referred to as parallel finishing. It's the smoothing pass. So I'm going to go back to, hopefully people can see this. Again, the metaphor is I do one side, I flip it over, I do the other side. Now the bottom, normally what you would do, unless you have a fairly advanced CAM system software, is you would simply make a clone of the drawing and flip it over and drop it into the same exact place in your drawing. In other words, top side of the spoon, bottom side of the spoon. I use an advanced version of Rhino CAM, and that allows me to redefine my work zeros. So the work zero is here, and click it here, and that's right here. But I can actually simulate the idea of machining from the bottom side. Notice that everything flipped over here. And now horizontal roughing shows from the bottom's perspective. There it is working on the bottom. And there it is showing for the machining. Now in reality, and if your CAM software doesn't support it, in reality, you're going to make two drawings. A clone of the drawing. You take this drawing here, then flip it over and do both sides. In terms of where you put your supports, it depends on the project. In this case, it's done in the middle. I'm going to end the share here, and I'll show you in more detail. Here, flipped over this way, it's symmetrical. So here's a board that I use for this kind of machining. And it's a board that I make up, I use for all kinds of two-sided machining. I'll explain all this stuff later. But essentially, this is a dinged up one that I had to where I didn't clamp it down. So here is, the bottom pass, and then this gets removed. It's pin registered. I use steel pins that are designed just for this. And then it gets put back on this way for the second pass. And everything's all lined up. It goes back in, and then I do the second side. Now, the origin point, and this is critical, that your CNC goes back to the same origin point each time. This is the trick that I use. So notice here, there's a 1/2 inch hole. It turns out that one of the things I use a 1/2 inch registration pin. I mount it in the chuck of my CNC. And then even though I know all the positions on my CNC, etc., when I do this kind of machining, we're definitely down to 1/1000th of an inch accuracy to be right to flip over in many cases. So I put a 1/2 inch registration pin in the chuck of my spindle and I drop it down into this hole. And that way I know I am aligned to the jig perfectly. So anything that goes on this jig, which is already set by these pin positions here, is going to be aligned. And that's how I do this kind of work. I do all kinds of stuff that way, and I have all kinds of boards for different uses. In this case, it's designed around a class that I teach to be able to do jewelry boxes. Now, these little slots here, the problem you have is when you get something clamped down there and it's all pin registered, it's tight. Getting it out is a problem. So I use one of these, and this gives me that gap I need underneath to pry up something without damaging the wood. That's why that's there. So that's at least a real fast introduction into the process. So next question. Let's see here. As a general comment from Chris Morgan. He brought up some good points. I know Chris, he's taken classes. We've known each other for quite a while. And to talk about design and production workflow, again, I use the software that I use. It may be different than other people's, but I'm going to give you a super fast run through a simple workflow and a more complex workflow that actually shows two-sided machining. So I'm bringing up a couple of drawings that I've had around here, and I'll show you. So down to this. So I'm going to share this screen. This is a French curve. So how I set up machining for this, so I've got this nice simple curve. I've already done the machine settings here, and I highlight that. The first thing that I typically do, if I'm making something out of plywood, in this case, I'm using this French curve, I may cut it out of an 1/8 inch plywood or some piece of plastic or something. The first thing that I do is I prefer to Z off the bottom when I'm cutting plywood, not the top. So the first thing I'm going to do is I'm going to move up this from 0 level up to, let me move over here. And of course, I would not be just my luck. I wouldn't have all my routines up here. I need box edit. There we go. So I'm going to position this. Let's see here. There we go. I'm going to move that up to, let's just assume it's 1/4 inch. It's simply easier to type. I'm moving it up off the surface. I'm going to Z off the bottom, so it sits off the bottom. Now, the process that I use, again, I'm using Rhino Cam, but other CAM software, the principles are identical. So one of the first things I do is I pick the tool that I'm going to use. I have a 1/4 inch mill in here. I'm not going to bring it up, but just trust me, it's a 1/4 inch. And then as safety, I typically go in and set my feeds and speeds now so that I get all that worked out. In this case, the default is set to cut at 120 inches per minute, or the way I have it set up. Then I have an important consideration is entry exit. If the CAM software you use comes from the machinist world where they cut metal, a lot of times they come in from the outside. So lines and arcs. So if you look at that, it would engage by running along the edge here. But I prefer with wood to run along the path. So in other words, it's going to actually cut down right into where it needs to get to work. And that's what this is about. And then I would exit the same way. Then cut levels, where I set the thickness that I'm going to cut. I have total cut depth to 0.68. This happens to be what I had it set up before, but let's just assume that this is one pass. And it's 1/4 inch. I was, again, trying to make it simple. 0.25 goes in here for my cut depth. Down below allows me to do it in levels. I could cut an 1/8 inch at a time. I could make those adjustments. Again, it doesn't really matter. In this case, other cut parameters. I want this to be cutting on the outside of this curve. So now I'm going to hit generate. And then I'll click here and I could see the tool paths, and you could see it cutting down. Well, I must have set it up for two passes, but it was making 2 passes down below. And that is a simple way in order to do this process. A huge amount about woodworking, CNC and digital woodworking is simply cutting out the outside and the inside of a part. And that's called profiling, and some programs refer to it as contouring. And I encourage you to consider the idea of, in your drawing, raise up the piece of wood in your drawing, the thickness that you're working from, and zine off the bottom. And this way you won't gouge into your table. The default for so much CNC work is to cut from the top. And that works in the metal world. It's less necessary in the wood world. And a big part of that has to do with the fact that we do care about the bottom. We don't care about the top so much. Now, if you're cutting very precision depths of some things, like you're cutting out a pocket of some sort, that may matter. But in wood, we have a lot of ways to make up for things that you cannot do it out of metal. So I'm going to go back here. Let's see here. I'm going to read a few questions here. Okay, so somebody said to the effect, depending on the drawing, the level of detail, Photoshop and Illustrator both have the ability to convert grayscales to vector shapes that can be used by CAM programs for toolpaths. This has to do with simply usually called bump surfacing of some sort. It's a fake version of 3D. If that's your goal, that's actually definitely a whole topic in itself. Aspire and some of the, excuse me, ArtCam and a few programs do that. They specialize in that. Most companies these days, they have some sort of option for that. For example, again, I use RhinoCam. They actually have an art plugin that does the same thing. That's a way to do it if you're trying to create 3D in a fake way, bump machining. Okay, so somebody said, I design all my furniture in SketchUp. This is a good question. I know where it's going. How difficult is it to go from SketchUp to CAD software? Are there programs that allow you to import SketchUp files as a starting point in CAD software? Well, I'm going to be real straight with you here. SketchUp is probably the worst possible program in order to ultimately end up doing machining on a CNC. And here's the reason. Now, it looks 3D in SketchUp and all that, but what it delivers as files, let's say you have a curve. Again, I'll bring this one up here. So you have this curve here, like this, and you're just trying to cut this curve along here. Now, as a straight vector-based curve, I mean, if you did this drawing from scratch in any kind of CAD software or Illustrator, this would be probably 5 control points to make this curve. So in other words, there would be a segment of a curve here, a segment of a curve here, a segment of a curve here, and of course, you know, on the bottom, the same thing would be true. SketchUp, for output into something that ends up on the CNC, will break this down into hundreds, if not thousands, of little tiny segments. That is a problem. I've cleaned up many, many files in SketchUp. For myself, I tell my students, please do not use SketchUp. What you need to do in terms of CAD software is import your drawings from SketchUp. I would encourage you to try to redraw the drawing. So if it's just you know, a shape of some sort, you've got SketchUp as your background, go and redo that curve using the SketchUp drawing as a reference. SketchUp and CNCs just do not work. As a result, the CNC will go cut, 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 and it'll just take forever, and a lot of times it crashes stuff. So how do you export DWG from SketchUp? You could do that, but again, it's going to be a million tiny line segments. There are YouTube videos and various things online you could study in this, but in the end, it almost always ends up that you're going to have to rework the drawing a bit in CAM. So let's see here. Looks like, not sure here. Well, are there any more last minute questions? And I apologize for the audio. It's those dang AAA batteries that died on me, and I didn't have them sitting here. That's my issue here. So any last minute questions? This is your chance. I think something is coming in. Nope, Not really. All right. So with that, if there's no more questions, I think we'll end the workshop today. I'm not sure what the topic will be. It'll be 2 weeks. Likely to be something, you know, pretty prepared. If you have suggestions as a topic or something, email them to me, tim@woodworking.digital, or fill out the form or something on woodworking.digital website. And then that's pretty much it. So I want to give special thanks to Joel Turner for co-hosting this. And again, apologies for the you know, the issue with microphones, but geez, live television, what can you say? These things happen. I'll try to have more demos. Last time I actually prepared a demo to show, because the question came up on 3D, how I did this. These are vice chops. These are, I don't know, 3.5 feet long or something like that. That was all done using flip milling to do the back side and the front side as well. So maybe that's something I might talk about, you know, in the next time we get together. Thank you very much again. And for today, I guess that'll be it. Thank you again.